Now the topic is Wheatstone Bridge. This is a circuit diagram of a Wheatstone Bridge. Usually the bridges that it consisting of four arms, 1, 2, 3, 4. Okay. Then in middle of that junction, I mean here C and D, the galvanometer is connected. The point A and B source will be connected. Okay. A bridge is a simple circuit consisting of four resistors as shown in the diagram. Bridge circuits are used to measure components values such as R, L, C. That is, any one of the component. Usually the R4 is an unknown value. Remaining R1, R2, R3 or inductor, capacitor is a known value. By this known value, this unknown value Rx or R4 will be, we can find it. Okay, that is the bridge circuits are used to measure the components values such as R, L and C. Its measurement accuracy is very high. A voltage source with a switch S is connected to point A and B. This is the voltage source with this with a switch. A galvanometer G is connected at point C and D. A galvanometer is sensitive microammeter. This is a sensitive microammeter. If there is no any current through the galvanometer, the points at O here, O means center, at the center. There is no any, if it is the bridge is in balance condition, there is no any current flow, the galvanometer, the pointer at 0. There is no any deflection in the galvanometer. The current at the galvanometer is at one direction, it deflects at one direction. If the deflects in opposite direction, if the current is in opposite direction, the galvanometer is center if there is no any current. If it is deflect in this direction, current, let us assume the current direction is in this direction. Suppose if it deflects here, the current flow is in this direction. I mean D to C. When switch S is closed, the current flows and divides into arm at point A, I1 and 2. And switch S is closed. Two currents, one is I1 at point A, I1 and I2 splits. Okay. If the bridge is at a balanced condition, there is no any current flow through the galvanometer. Okay. If a bridge is in balanced condition, there is no any current flow through the galvanometer. Okay. The potential across C and D is same. If there is any potential difference between C and D, the current flow will be there. Okay. Since at the balanced condition, C and D will be same, there is no any current flow through the galvanometer. The bridge balance equation can be obtained by a current and resistors. Balanced condition, I1 into R1 equal to I2 R2. I1 into R1 equal to I2 R2. That is C, there is no any, what is the balanced condition? There is no any current flow through the galvanometer. If there is no any current flow means C and D at same potential. So I1 into R1 is equal to I2 into R2. CD potential is 0. I1 equal to I3, I1 equal to I3. Since it is there is no any current flow, the entire current is flow through the here, that is through R3, that is I1 equal to I3. Similarly, I2 equal to I4, that it is given as a total voltage source E divided by R1 plus R2. Similarly, this one. Substituting 2 and 3 in equation 1, this 2 has to be substituted here, equation 1, that is R1 into I1 value, this one. Similarly, R2 into I2 value, this one. So E get cancelled, remaining is R1 divided by R1 plus R3 equal to R2 by R2 plus R4. Then cross multiply, R1 into R2 plus R4, similarly R2 into R1 plus R3, multiply. Then here also R1 into R2, here also R1 into R2, cancel. R1 into R2 equal to R2 R3. Finally R4 is R2 into R3 divided by R1. The equation 4 is the condition for balance. Therefore, in practical, one resistor is made adjusted to obtain the balance condition. This is usually R4 is a unknown value. We have to connect here the unknown value of a resistor to find it. Any one of the resistor you have to make adjustment to make a galvanometer is 0, to make the bridges to the balance condition. That is given here. In practical, one of the resistor is made adjustable to obtain a balance condition. The unknown resistor is normally connected to R4. By adjusting adjustable resistor to make the galvanometer is 0. Therefore, Rx or R4 equal to R2 into R3 divided by R1. Sensitivity. What is the sensitivity? At a balanced condition, there is no any current flow through the galvanometer. The current is 0. If there is any small current flow at a balanced condition, means that sensitivity is somewhat lesser, though that it is given at here. At balanced condition, the current flows through the galvanometer, causing a deflection of its pointer. The amount of function of the sensitivity of the galvanometer, D equal to S into I, current. Okay. Then limitation and disadvantages of Wheatstone bridge. For low resistance measurement, contact leads becomes a significantly introduce an error. Here you are having a contacts, here, that it leads a problem. Low resistance measurement, contact leads become a significant introduces an error. For a high resistance measurement, the galvanometer is insensitive to unbalance. Because of a high resistance, there is no unbalanced current through the galvanometer. If the value of a resistance is very high, means that it also causes to, there is no flow of current to the bridge. That's also a problem. Therefore, battery or power supply has to be increased. So to increase the current flow, we have to increase the power source. The rise in temperature causes a change in value of the resistor causes the error. If rise in temperature causes a more current flow, that it is also causes the error.